Hello everyone, welcome to the lesson level 200. My name is Flavio Pereira and I'm part of the Field Enablement Group at Oracle Cloud Infrastructure. This lesson will cover on details topics that were not covered on Compute 100 level course, so it's highly recommended that you watch the first Compute lesson in order to follow the content on this course. So here's our safe harbor statement. I'm going to pause for a few seconds here so you can read the statement. All right, so in this lecture, we'll dive deeper into the OCI compute service and talk about concepts and look at various features for compute, right? So after we finish this lesson, you should be able to describe high availability and disaster recovery in OCI, understand how instance configuration and pool works. We're going to talk about instance console connections, so you're going to understand how you can troubleshoot a malfunction instance in OCI. We're going to describe how you create custom images, how you can import and export, how you can bring your own image to OCI and also bring your own hypervisor as well. We're going to talk about some GPU images available in OCI and cloud-init and instance metadata. All right, so just to give it a brief overview from the previous lesson. So we are the only public cloud which supports bare metal and virtual machines using the same set of APIs, hardware, firmware, and software stack and the network infrastructure, right? So you can see here on this slide, we have two models. We have the bare metal instances where customers can get the full server dedicated to them. This is also referred to as a single tenant model, right? So only the customer has access to the server, is only dedicated to them. On the other side, we have the virtual machines where the underlying host, right, is virtualized to provide a smaller virtual machine. So it's also referred to as a multi-tenant model. So the advantage here is the flexibility in regards to choice of instances shapes, okay? So we have bare metal and virtual machine, all integrated and using the same network infrastructure. All right, so let's go and talk about some of the concepts here around high availability and disaster recovery. It's really important to talk about this topic as you design your application and putting a workload in OCI to understand how you can spread those workloads, taking advantage of the regions, availability domains, and fault domains. All right, so one of the key concepts here on OCI is the flexibility to use multiple availability domains and multiple regions, right? So on a single VCN, you can create multiple subnets and place those subnets on each availability domain. So when you're doing that, that's give you the ability to spread your workload in multiple compute instances, creating, for example, a cluster, right? So as you can see here on this slide, I'm taking advantage of the subnet and creating compute resources spread among those subnets, right? And I can have a cluster configuration scenario for my workload on that case, right? So that actually give you the extra hardware and software, right? That will increase the reliability of your workload, and in some cases can improve performance as well, as you can scale up and down your workload. All right. So when designing a high availability architecture as well in OCI, it's always recommended to avoid a single point of failure, right? On the previous slides, we deployed the compute nodes using one availability domain and placed them on a specific subnet, right? So we have recommended design your architecture to deploy compute instances that perform the same tasks in different availability domains where the power and the cooling are isolated from each other. So as you can see here, we can now spread the workloads among availability domains. So the third option that we have here is what is called fault domains that can provide a high availability for application resources inside of a single availability domain. So by protecting against unexpected hardware failures and maintenance updates on the computer hardware. So as you can see, we have a region, we have the availability domains, right? And in each availability domain, we have what we call 3 fault domains. So it will help you to distribute your instances so that they are not on the same physical hardware in a single AD, right? So as you can see, we're spreading the workload here on those fault domains. All right, so you can also spread your workload in multiple regions, and that gives you the ability to create a disaster recovery architecture for an application. So those regions, they are connected, so you can have your production workload to a region that's close to your customer, and have a DR site in a different country or even continent, right? This also allows you to store data in regions where you have specific requirements, such as tax domain or legal restrictions, or even data residence issues, right? So that gives you the ability to have your data placed in a different region. As part of disaster recovery plan, you can connect those regions using a feature that's called remote VCN peering, right? So this allows your compute instances in different regions talk to each other without the need of complex network configuration. With only the DRGs on each side of the region, you can connect those, and this is gonna use the internal backbone, and the traffic never leaves the Oracle network. So it's internal backbone that make those communications possible. So now let's talk about the specific details of compute service in Oracle Cloud Infrastructure. We'll start with instance configuration and pools. So instance configuration, right? Instance configuration define the configuration information to launch a compute instance. So here we have a running instance, and then from that running instance, I can create an instance configuration. That instance configuration will include parameters like operation system image, metadata, shape, and related resources as single configuration entities. So you don't have to specify them every time you launched a new instance, okay? On that configuration, there is like configured attached storage volumes, virtual networks, subnets, and AD placements, all with a single request, okay? So based on the instance configuration, I can provision and create multiple compute instances based off the same configuration on the same region, right? So that gives me the ability to create multiple instances at the same time. And one advantage of it, I can spread those instances in multiple availability domains inside of that specific region. So that gives me the ability to implement in the future the outscale, right? So if I need to outscale my resources, I can use the instance configuration to increase the amount of resources for my workload, right? So as I said, you can put that on different availability domains, and you can manage all together. You can stop and start, terminated all the pools together. So it's easy to manage your pools. So here you can see some use cases for instance configuration and pool. So for some use cases for instance configuration, right? So you can clone an instance and save to a configuration file. You can create baseline instances templates, right? You can automate the provision of many instances, so it resources and handle the attachments. So it's easy to create a standard and a template and create multiple instances using instance configuration, right? And the pool will actually give you a central place where you can manage all your workloads using a consistent configuration. And if you need, for example, update a large number of instances, you can do that with a single instance configuration change. So it's it's easy to do that if you want to make a change to a specific set of instances, right? You can scale out instances on demand by increasing the instance size of the pool. So you can pick up configuration and say, I want to create 10 instances from there, and then you increase the amount of of instances on that pool. All right, so now let's go and talk about instance console connections and how that can help us to actually fix problems on malfunction instances in OCI, right? So what exactly is instance connection? So when you're working and deploying compute instances, you can get in the situations where compute failed to boot because of a misconfiguration in the operation system, or a problem with a specific driver that could not load during the boot, or maybe something happens in your instance that you'll be stuck, and where you don't have access to the network, right? So you won't be able to do SSH, and you won't be able to do RDP or access that instance through the network. So you must access to we call it backend, right? So through a serial console connection, so you can see the screen and be able to troubleshoot and understand what happened with that instance. So with instance console connections, you can access that, right? You can get the same experience as using a serial console. You'll be able to access an instance even if you don't have network connectivity, like I said, and then gain access to the instance screen, right? And from there, you can perform a lot of tasks. For example, you can add or reset an SSH key for the OPC user. You can fix it, imported or customized image that you created and was unable to boot, wasn't able to complete the boot successfully. You can troubleshoot that. Or maybe just an instance that was working and then stopped responding. So you can use the instance connection to troubleshoot that, right? So there are two types of instance connections available in OCI: serial console connection and VNC console connections. So you'll be able to access on two ways here. So how you create that instance connection, right? So before you actually access, you have to go to the instance itself. And then on the resources portion of instances, there is a create console connection button. So you can just click create console connection. And once you do that, you have to specify the public key portion of the SSH key and then click create console connection. So this SSH key doesn't have to be the same SSH key that you use to launch on your instance. It can be a different SSH key, and I recommend that you use a different one. So you can have a little bit of control of which keys are used for SSH connections and which keys are used for instance console connections. It's always recommended that you don't give access to everyone to your instance console connection, as you're going to give access to the server even if you don't have a network connectivity. So it's highly recommended that you create a policy, a YAML policy that can isolate the amount of users that have access to instance console connection. Okay, so once you create it, you're gonna see that the console connection will become active, and you can see a green sign saying that the instance connection is now ready to be used. So when that happens, you can just connect click on the action button and then choose which type of connection you want to do. You want to do an SSH, or you want to do or connect through the VNC, sorry. So you can choose one of those options. So if you choose to connect to with SSH, you can see there's like Linux, Mac OS. That's the platform that you actually are using on your own laptop or your own desktop to get access to the server. If you're using Windows, you're going to have a command, which is a PowerShell command that you can execute it in order to get access to the server, right? So you can copy that string that's presented to you, and then you can execute and just hit enter and then connect to the console. So just to give an idea, this is one of the string that you can copy, right? So as you can see here, we're just talking about the string and how it's how it works. So you're doing an SSH on port 443, And the username here for the SSH is actually your instance console connection, the OCID of that instance connection that you created. And you're connecting to a console connection server. So there's a jump host behind the scenes to support that console connection for all the servers. In this case is that URL, right? The instance console usphoenix.oraclecloud.com. And then the instance where you want to get access to, right? Which instance you want to get access on the console. So this is actually the string that's going to use the SSH key you provided, right? So you have to provide your private key on that SSH command. And then once you do it, you're going to get access. You're going to see something like that, right? You do SSH and you provided the key, and then you're going to get access to the login screen. Right. So once you get access here, you might think, okay, I don't have a username and password in order to get access to the instance. And that's totally fine, right? And we recommended that you don't give any username and password on that screen either. So as you know, to get access to the instance, you must have an SSH key. For the Linux instance. So for RDP, you have a username and password, right? But using SSH is the best way here to protect your instances. So once you get to that screen, you can just reboot the instance. And then once you reboot it, you can inject some parameters configuration on the kernel line. For your Linux instance, you can type init equals /bin /bash, and then you're gonna get access to the root partition of your server. So from there, you can mount any extra volumes that was associated to the instance. You can troubleshoot any problem you have inside of the operating system. You can replace SSH keys, right? You can change files, change configuration, and so on. Once you're done, you can just reboot the server one more time, and then everything's going to go back to normal again, right? So for security reasons, right, when you finished with the serial console, when you finish your troubleshooting set, please go ahead and terminate the SSH connection and delete the serial console. So you don't want to leave the serial console active on your instance for security reasons. And if you do not disconnect from the session, OCI will terminate the serial console after 24 hours, right? And then you need to re-authenticate to connect again in case you need access, right? All right, so let's now talk about custom images and import and export, and understand how that works, how you can customize images in OCI. So custom images will allow you to create a base image of your instance where you include the OS or operating system and the application's binaries installed on the root partition. So it's important here to mention that the custom image will not include data from any attached block volumes. It's only get the data from the boot volume, from the root partition, right? Also make sure that your custom image is not over 300 gigabytes. That's a limit, so you have to pay attention to it. And after you create a custom image, you can also export it. So you can export that image to use, for example, in another region or another tenants. But keep in mind that Windows images cannot be exported because of license agreements. So as part of the OCI, we have shapes that we call in two different type of hardware machines, right? X5 and X7 machines that are base host hardware. So when you're creating an image using X5 shape, it's recommended that you use the same X5 shapes for your target machine, right? So some of the pre-built images in OCI support the cross-compatible hardware, right, between X5 and X7. So Oracle Linux Ubuntu 16.04 are cross-compatible. The only thing you have to do is make sure you update the kernel with the latest drivers. And then in case you create an image on X5, you can do that and place that image on X7 machines as well, as long as you have the latest drivers. So that'll be fine. All right, so here's how you can launch a custom image, right? So once you created the custom image, so on a running instance, there is a button. You can go there and just say create a custom image. After you set up your application, put the binaries on the root partition and everything is ready, you can create that image. And then from there, you're going to see the image is going to be available to you, and you can just create an instance from there. You can go on the console, on the action button, and just say create an instance. Right, and then you choose which compartment you want to place that instance, right, and launch it. Right, so you also have the ability to import and export an image. All right, so you can also have the ability to import and export an image, so you can move images between regions and tenancies, right? So all images imported and exported will be placed in a bucket of your choice in object storage. And there are some import modes that you can use for your image. So first option is emulated mode, where all the drivers for network and boot disk are fully emulated. The second option is the native mode, where it offers the maximum performance as the drivers are directly connected with the hardware and will be a good fit for bare metal instance. And the third mode is the para-virtualized or the PV mode, right? Where this capacity minimize overhead and optimize performance, allowing new operating systems to take advantage of that, right? So you have three options when you import an image to OCI and be able to deploy that on the platform. Here's more information where you can find about custom images, so you're welcome to check on that link and get more details on it. So when should I use custom images or boot volumes backup, right? So it actually really depends on the type of workload and how you want to manage the copies of your templates, right? So custom image is more a type of creating a golden image that can be used to deploy 100 of instances based on a specific configuration, right? Where the boot volume backup is great feature to roll back misconfiguration into the operating system, or even if you apply a patch and then something went wrong with the operating system, you can just roll back that boot volume, right? So it really depends on the type of workload and the application that you actually putting on the platform. But here you can see some advantages and disadvantages of custom images and boot volume backup. All right, so let's talk about bring your own image or hypervisors, right? So most of enterprise organizations, they have their own images created on premises, and then the ability to bring those images over to OCI will save configuration time, as you can import the image as it is and then launch that on three different modes that I was explained earlier, right? So you can choose an emulated mode, a native mode, or a para-virtualized mode. So it really depends on your image that was actually built on premises and what kind of virtualization or hypervisor you have on premise, or what kind of hardware you have. So you can choose one of the three options when moving those images over to OCI. Right? So you can import a wide range of new and legacy operating system as long as you have it on a key call 2 format or VMDK format, right? So then you can bring those images over and run that as we call emulated mode in OCI. So here's the table that actually give you an idea of the images that you can bring over and the supported versions. So you can see you have old versions like Oracle Linux 4.5, Ubuntu 12.04, some of the Windows operating system as well. Right? So you also have to keep in mind that you must meet a few requirements in order to bring your own image. So first, make sure the image is set up for BIOS boot. So that's one thing. The second, the image must be under 300 gigabytes. So make sure that your VMDK and key call is a single file, as multiple files is not supported when doing the custom image, right? Existing network interfaces will not be recreated, so all the configuration you have in your network card, that's not going to be brought over. So it's recommended to use DHCP for your configuration, and then once you deploy that in OCI, let the OCI take care of the configuration for the network, as you're going to place that on a specific subnet, and then you can get the IP address from that specific VCN. Right? So bring your own hypervisor. We actually support 3 types of hypervisor that you can bring over to OCI. We support OVM, so it's Oracle Virtual Machine, KVM, and Microsoft Hyper-V. Right? So there's some benefits in bring your own hypervisor, right? So that's give you the flexibility of customize your virtual machine in shape, and you can select the amount of CPU and memory required for your workload. So you can control the hypervisor and then be able to slice the amount of CPU and memory on that specific host and associate that to your guests, right? As it's a unique feature of OCI, so you can leverage services like block volume and network interfaces that can be directly attached to the virtual machine, and you can that was created on top of your hypervisor, and that's going to allow them to communicate with other resources and instances provisioned in OCI, right? So for your guest, it's going to be transparent. It seems like it's part of the VCN. You can recognize other resources or other instances that you launched on a platform. But it's actually your guest is sitting on the hypervisor that you decided to install. So just to illustrate, we can have just illustrate that right. So we can have multiple virtual network interfaces in different subnets, and as you can see here, we have a bare metal instance, and you have 3 guests that was created. And then you can see each guest has this virtual network interface, and that network interface is associated to a specific VNIC inside of a subnet, right? You can have multiple VNICs associated to your host, and then associate that to a specific guest as well, right? So one of the use cases for secondary VNICs is when you have the bring your own hypervisor scenario, right? In that case, we use what we call this technology called SR IOV technology, and that's going to provide separated virtual NICs for each virtual interface, right? Okay, the guest can have a private and a public IP, so you can associate a private and a public IP to the guest, and that's going to be part of your subnet. Okay, just keep in mind that each shape has a limit of the amount of VNICs you can have, so please check the compute shapes documentation to get more details and information. All right, so in order to speed up the hypervisor configuration, OCI offers a pre-built image for KVM hypervisor. So if you have KVM and you want to bring that over to OCI, you don't have time to actually go to the installation process of KVM and install the binaries and all that. So you can use a pre-built image that we offer to spin up and launch that instance with KVM already installed. This image is part of the Oracle Partner Catalog, and provide a set of tools that can interact with your host, right, and the hypervisor, and can actually help you to create virtual machine guests. So there's a set of tools that came with that image, right? As of today, we support bare metal standard and bare metal dense IO shapes as part of that deployment. So when you pick up that image, you must select one of those 2 shapes in order to spin up that KVM image, right? So as you are in control of all the virtual machine configuration, right? All the guests that you want to create on top of the hypervisor. You need to pay attention to the amount of CPU and memory and storage disk associated with each VM, right? So you're also responsible to create and attach those resources as needed. So you're in control of, creating a block volume and the size of that block volume and associated that to a specific guest, along with all the network and actually the CPU and memory, right? So always pay attention to the amount of CPU and memory you have on your host, so you can spread that over to the guests you create on top of that. So on the image, on the KVM image, there is a set of tools, like I said, to help you to create guests. And here's an example of a command line called OCI KVM space create that's gonna give you an idea how you can create a guest, how you can associate a block volume to that specific guest, the internal IP, right? The amount of CPU and memory that you want to associate with that. Okay, so once you created the guest, you can use regular KVM tools like verse commands to start a guest and to check all the guests that actually up and running on your KVM host. All right, so let's just talk about a little bit of NVIDIA GPU images and how that works in Oracle cloud infrastructure, right? So NVIDIA makes available on OCI a customized compute image that's actually optimized for the NVIDIA Volta, Tesla Volta, and Pascal GPUs, right? So NVIDIA also offer GPU Cloud, or they call NGC, that can provide containers for machine learning, deep learning, and high performance computing as well. So when you provision an OCI image for GPU, you can easily start a Docker container inside of that instance and then start running your deep learning jobs, right? So all the GPU images are prepared with the set of tools that NVIDIA provide for you. So CUDA driver, everything is going to be installed on that specific image. So you're ready to go to start using the registry that NVIDIA provides to you in order to pull those containers and then start running your machine learning, your deep learning jobs as well. Here's a list of instances and shapes that has GPU cards on it. So as you can see, we can run GPU on bare metal and virtual machine shapes. And you can see the amount of GPUs, the amount of cores, and the amount of memory associated with each one of those shapes, and what kind of GPU type you have it, right? If a Tesla Volta GPU or a Pascal GPU. And you also have access to what we call the NVIDIA NVLink that will provide a higher bandwidth interconnect between the GPU chip, and that's going to increase performance for your job, as the GPU can talk to each other through that NVLink. All right, so let's talk about cloud-init, metadata, and understand how that works, right? So users, they often want to do some configuration to the instance during the launch, right? When you're creating the instance, and right after the machine just booted up, you start creating, executing some scripts to maybe create a directory, insert users, or do some configuration inside of the operation system, right? So for example, you may want to install some packages, start a service, or manage the instance using, for example, a configuration management tool like Puppet, Ansible, or Chef, right? So when you launch an instance in OCI, you can use cloud-init. Cloud-init is for Linux, or cloud-base-init, which is for Windows, that can support that automated configuration of instances in a boot time. So, and why would someone actually use it, right? Like I said, it's easy. You're going to facilitate you to actually configure an instance. And as you can see, you can set a host name, you can configure SSH keys, you can install packages, you can run commands in script, right? It's very useful when you have to install a lot of identical machines or very similar machines with the same installations and configurations, and only or only one machine that has a lot of complex configuration details. So it's easy to do that with cloud-init. Here's an example of a cloud-init and user data script, right? So as you can see here, there's a cloud-init script that will go over and install a LAMP stack, HTTP, MySQL, PHP, and created an index.html file, sorry, a PHP file. And to get access to the cloud-init, when you're launching your compute, there is an advanced option, and under that advanced option, you can provide your cloud-init script file, or just paste the cloud-init script on the box. Okay. All right. So instance metadata. So instance metadata is like, every instance store its metadata on what we call a metadata server. So Oracle OCI has this instance metadata server, which is running on 169.254, 169.254. And then if you SSH to a computing instance, you can just query the metadata server using curl commands, and then you can get access to the metadata. So what exactly it is, right? So the metadata server, you can find information about the instance, such as instance host name, instance OCID, custom metadata, regions, availability domain, and etc. Right? So there's a lot of information about the instance itself on that metadata. The metadata is actually useful when you're using a combination with cloud-init that we just described before, right? So because you can use the metadata server to get unique information about an instance, right, without additional authorization. So you don't have to log in or any specific authorization in order to get that information. So for example, you can write a script that gets the metadata key for an instance private IP, for example, and you use that IP in your script to set up a database, right? It can work really well in conjunction with the cloud-init scripts. You can also create a custom metadata and use it on your scripts as well, right? So you can provide a specific key and values to your metadata, and for the same reason, right? So let's say you have an application that reads a specific metadata attribute, and based on that value, you're gonna take some action, right? For example, like register instance against a specific configuration management tool, or you want to pull a data set from object storage in order to do some analysis, right? So you can configure a specific value and key for your custom metadata, and based on that information, you can take actions like that to do some configuration or some analysis for you. All right. So in summary, we went over to how you can architect your applications for HA and DR in OCI. We talked about instance configuration and pool. We went over some of the instance console connections and how you can troubleshoot your malfunction instances. Use custom images to create templates and customize your operating system. We spoke about emulated, native, and para-virtualized mode when you bring your own image, how you can use the pre-built KVM image in OCI and take advantage of bring your own hypervisor. What are the options for NVIDIA GPU NGC registry available in OCI, and how you can use cloud-init and metadata on the compute as well, right? So that was our lesson. So thanks for watching and have a good day.